Dmitri Mendeleev, a Russian chemist and inventor, developed the periodic table during the mid-19th century, creating a system that organized all the known elements at the time and, impressively, even predicted the existence of elements that had not yet been discovered. As we saw in our earlier video on elements, everything in the universe is made from various combinations of the elements found in this table. The periodic table, much like a book, is read from left to right and top to bottom, and the elements are arranged in order of increasing atomic number, which indicates the number of protons in the atoms of each element. Within each box on the table, you will find three key pieces of information. The element symbol, like Na for sodium, appears prominently in the center. The atomic number, which tells you how many protons the atom contains, is placed at the bottom left, and the mass number, which shows the total number of protons and neutrons combined, is found in the top left corner. While organizing these elements, Mendeleev noticed that certain chemical properties repeated at regular intervals. Rather than laying all elements out in one long line, he started a new row whenever a pattern of properties repeated, and these rows are what we now call periods. Because these chemical patterns repeat, each vertical column, called a group, contains elements with similar properties, and the groups are numbered from 1 on the far left to 7 on the right. For example, the column we're focusing on now is group 2. There are a couple of exceptions to this straightforward numbering. The last column on the right is called group 0 instead of group 8, and the block of metallic elements found between groups 2 and 3 are called transition metals and don't follow the usual group numbering. For now, just remember to skip over them when counting groups. The reason elements within the same group have similar chemical properties is that they all have the same number of electrons in their outermost shell, and this outer shell is crucial in determining how an element behaves chemically. In fact, the group number directly tells you how many outer electrons an element has. So, in group 2, every element has exactly 2 electrons in its outermost shell. It's important not to confuse this with the total number of electrons an element has. Different elements within the same group can have different total electrons, but their outermost shell always contains the same number. Take group 1, for instance, which contains the alkali metals. All of these elements have 1 electron in their outer shell. Lithium has 3 electrons overall, while sodium has 11, but both share that 1 key outer electron, and this similarity is what gives them their distinct reactivity, such as their famously violent reactions with water. Additionally, there are trends that occur as you move down a group. In group 1, for example, the elements become more reactive as you move downward. We'll explore this in more detail in a separate video dedicated to group 1 elements. Similarly, group 7 elements, known as halogens, all have 7 electrons in their outer shell, but they become less reactive as you go down the group. As mentioned earlier, group 0 is unique. These elements are the noble gases, and they all have completely full outer shells. Argon, which has 3 electron shells, has 8 electrons in its outermost shell, while helium, with only 1 shell, has 2 electrons, which is the maximum that the first shell can hold. Because their outer shells are full, noble gases have no need to gain or lose electrons and are therefore extremely unreactive. Sometimes, you might see a zigzag line on the periodic table, running diagonally from aluminium to polonium. This line separates metals, which are mostly on the left side and are often shown in orange, from nonmetals, found on the right and shown in blue. As you can see, there are significantly more metals than nonmetals on the table. Nestled in the center of the metallic section are the transition metals, which form a special group of elements that we'll explore in another video, along with a closer look at groups 1, 7, and 0, and the differences between metals and nonmetals. Before we wrap up, one more important point. If you search for the periodic table online, you might come across various layouts and designs. Sometimes, the positions of the atomic number and mass number are reversed, like in the case of iron, but don't let that confuse you. All versions of the periodic table present the same essential information, just in slightly different formats. You can always identify the atomic number because it will be the smaller of the two numbers. Also, in your exam, you'll be given a periodic table that looks similar to the one we've used throughout this video. That's all for this video. If you enjoyed it and found it helpful, please give us a like and subscribe to the channel. We'll see you next time when we continue exploring the fascinating world of chemistry.